Okay, so we are going to do the point of trajectory or point of convergence for blood drops today using the trajectory of the blood drops. When we are doing this, you're going to find the angle of your blood drop like we did last week, and then you're going to also, kind of like we did with bullets, draw lines to find out where the blood would have come from and then calculate the point of origin from there. So the first thing to remember is to calculate impact angle, you have to do width divided by length equals sine. So impact angle is width divided by length equals sine. That decimal that you get for sine is how you find the angle. You can do that using math, or for in our case, we have our data table. So you're going to use your chart. We are also going to need tangent for this. So to find the actual angle, you find the decimal that's closest to it on the center column of the table. That tells you the angle itself. You're also going to need the tangent, which is that second decimal on the chart. So we're going to go to the full number today, not to the half. So find the one that's closest. And then our new thing that we're going to do today is the height of point of origin. You can't tell me how to find them. And to find the height of point of origin, you're going to do the tangent of the angle, which is off of your chart, times the distance to point of convergence, which you will measure from the picture. So we're going to come back to this equation in just a second. If you are like me and like to do different colors, 3 colors are going to be needed today because we have 3 different blood drops. So you have your data table here. We're going to first calculate our impact angle, then we'll measure our distance to point of convergence, then we'll calculate our height. So this is going to be math. This is going to be measure. And this is going to be math. Yes. Sorry. Okay, so you're going to go to your first blood drop here. And remember, you only measure the original blood drop. You don't include the tail when you're doing your length measurements. And for each blood drop, we're going to make ourselves a little data table of sorts. So we're going to need the width, the length, that will then solve for sine. Then we'll find our angle and we will write down our tangent. And then at the end, you're going to have your POH, or point of origin height. So these are the things we're going to do for this blood drop. We're still using our ruler. We're still in millimeters. So for width, you go to the fattest part of the drop from side to side. Let that focus for a second. And we are at 5, 6, 7 on my ruler. So my width is 7. We're going to go to length. And we are at 25, 6, 7 for length. Then we've got to do a little bit of math. You're going to do 7 divided by 27 equals, plug that into your calculator. 7 divided by 27 equals, 4 decimals are on our chart, so keep 4 decimals as your answer. Just makes everything nice and simple. So we are going to do 259. The 2, the 5 in the 5th spot rounds that 2 to 3. So our answer is going to be 0.2593 for our sine. You're then going to go to your chart. You're going to find the one that is closest to that. So 2588. So our angle is 15. And our tangent, we are at 15. That was the sine that we calculated closest to. And then our tangent is this last one. So 2.2679. And then we'll come back to the point of origin height in a mid. And then last for this blood drop, we are going to draw a line directly through the middle of it. Through the entire crime scene. Now let me zoom out a little bit. So I've drawn the line back through the crime scene, but remember the tail tells us where it's going. So some altercation happened over here, resulting in blood spatter, and it spattered that direction. So this blood drop is moved in that direction. Okay, so then for your second dot, you do the same thing. So we're going to do the width of the blood drop. So we're at 1011. Width is 11. Length is 26. Sine is width divided by length, giving you 0.423. That 7 talks to the 0, making that a 1. When you're rounding like math, go to your paper, find 4.2. We're closest to 25, so our angle is 25. And then our tangent is 0.4663. Come back to POH in a second. Yep. And then you're going to draw your line through the middle of your blood drop. We're creating a cross section here. Hopefully, if this blood drop also came from the same impact, that will cross as well. And you will get a point of convergence. So we're going to do our third blood drop. Width. Yep. Width of this blood drop is 7. Remember, don't include the tail. Length of this blood drop is 35. Sine is width divided by length. 7 divided by 35 gives you a nice solid number. Find it on your sheet. 0.2 is 12. It's closest to 12. Tangent is 2126. Draw your line through the middle. And we now have a general area where all those blood drops came from. And we're going to pick the spot where they 3 intersect. And that's going to be our point of convergence, which we will then use to find our distance to point of convergence. So this is our point of convergence. So we are looking at what we've got. Let's zoom back out. So we're looking at all of our stuff here. Our data table wants our impact angle. So our impact angle for blood 1 is 15. Our impact angle for blood 2 is 25. And our blood impact angle for blood 3 is 12. We already did the math, it's all set up. Now we have to find the distance to point of convergence, and you're going to measure the lines. So you might make yourself a note there. You're going to measure the lines. So we'll go from the front of the blood drop to the point of convergence. So from here to there, we are at 96 for blood 1. For blood 2, we are at 60. And for blood 3, we are at 106. So just measured from that blood up front of the blood drop to the point of convergence. Now we have to do some more math, and that's what this POH is holding our place for. So we're going to take the tangent of our angle times the distance to our point of convergence to get the height of our point of origin. So our tangent we found on our sheet. Let's zoom in. So we have 0.2679. Your distance is coming from your table, so 96 multiplied by 96, giving us 25.71. You can write it with your decimals if you want. I'm going to round, so my height for bullet 1 is going to be 26. Bullet 2, or not bullet 2, blood 2, we're going to have 0.4663 times, so tangent times the height, or the distance, equals the height. 27.978. I'm going to round to 28. Tangent times distance. My distance for this one was 106 equals 22.5356. So I'm going to round that to 23. So you've now calculated your angle using the width and the length of the blood drop. Then you find the decimal you get from that on the chart. You've measured the distance to the point of convergence by measuring the lines. Point of convergence is where the lines intersect. And then the point of origin, or the height of the point of origin, is the tangent of the angle times the distance gives you the height of the point of origin, which is how far from the crime scene 2D model is, how far into space the point of convergence actually is.